Welcome to today's webinar, Deep Dive on Amazon EBS Elastic Volumes. Our presenter today is Daryl Osborne. Today with us we also have David Stein, Suraj Prasannan, and Ruchan Nene. They will be our moderators today and will be engaging with you and answering your questions throughout the presentation. Daryl Osborne, welcome. The floor is now yours.
Great. Thank you, Joe. I appreciate it. As Joe mentioned, my name is Daryl Osborne, and I'm a Storage Specialist Solutions Architect. And I, too, want to welcome you to the webinar. The EBS has a long history of providing block storage to EC2 instances. After launching magnetic volumes back in 2008, we learned a lot, and we learned that we needed to provide consistent performance. So in 2012, we launched EBS provisioned IOPS. We also call them iowan volumes, and I'll be referring to them as iowan volumes during today's session. We also launched at that time EBS optimized instances. They allow you to specify a consistent IOPS rate when you create the volume. And we deliver within 10% the provisioned IOPS performance 99.9% of the time. So iowan volumes are really designed to meet the needs of IO-intensive workloads. So following the launch of iowan volumes, we looked at the performance across our EBS fleet, and based on our analysis, we designed the best suited volume type. So in 2014, we launched the general purpose volume type, also called GP2, which really uses a burst bucket or a burst model. Not a lot has happened in the industry around magnetic volumes. So in 2016, we decided to be disruptive. So we launched the latest HDD volumes, the throughput optimized or ST1 volumes, and the cold storage SC1 volumes. Then, of course, we launched we brought elasticity to Elastic Block Store with the release of elastic volumes earlier this year. So when choosing volume types, it's important to know your workload. Are IOPS more important or throughput? Keeping in mind that some applications will have different types of workloads, and each EC2 instance can have volumes optimized for either IOPS or other volumes optimized for throughput. This gives you the flexibility to have a tiered solution. Now that you know whether your IOPS or throughput is more important for your different workloads, let's spend a few minutes reviewing the different EBS volume types. Our GP2 volumes are SSD based and are great for really the majority of workloads out there. That's why we designed them that way. These are really good enough volumes, good enough for the most typical workloads. For extreme IO-sensitive workloads, which needs consistent IOPS, we provide iowan volumes. They are able to, and you're able to select the IOPS you need for your workload. You can go all the way up to 20,000 IOPS per volume. Last year, we released the ST1 volume, which is ideal for large block, high-throughput sequential workloads, being able to get up to 500 megabytes per second per volume. We've seen a lot of excitement around this ST1 volume from our big data and analytics customers, where they're able to get just as good or better throughput numbers and performance compared to iowan, but at a substantial cost savings. Then finally, our SC1 volume. It is a complement to our ST1 volume and is great for sequential workloads like backups or even logging. It has less throughput compared to the ST1 volumes, but its price is substantially lower as well. So these are great for burstable sequential workloads like logging or backups. So this decision tree can really help you narrow down your choices so you can make the correct decision on which EBS volume type to choose. I don't want to spend too much time with this slide, but I just want you to know that it is available. You can refer back to it at a later time, so it will help you walk through the decision so you can select the correct volume type for your workload. We're very pleased and excited to introduce a new level of elasticity to Elastic Block Store. Throughout this presentation, you'll notice a trend. You'll notice the number 3. You'll see this pop up a number of times. So just keep in mind and keep this at the top of your head that so that you'll be able to recall some of the things that you review today. So just keep in mind that 3 is going to sort of be a theme throughout the session. Throughout our discussion also, we're going to see a number of different icons. They may have different colors and different designs, but they're going to depict EBS volume types. The new Elastic Volumes capabilities allows you to modify certain volume characteristics. The modification process is going to be depicted in our slides as an arrow. The original volume will always be at the end of the arrow, and I'll try to refer to this as the original volume. The target volume will be at the tip of the arrow, and that's going to be the end result volume, how you want to end up at the end of the modification process. And I'll refer to this volume as the target volume. So, what are the new capabilities? Well, I'm sure you could guess there are 3. 3 new capabilities we'll talk about today. You can increase the volume size, you can change the volume type, and you can increase or decrease the provisioned IOPS of iowan volumes. So let's dive deeper into all 3 of these. So you can increase the volume size. In this slide, we see smaller volumes able to increase into a larger volume. Everything else stays the same. You're just basically increasing the size of the volume. The next capability, or one other thing I want to point out as well, is that this is an increase only. You cannot decrease the volume size. You can only increase the volume size. So you can also change the volume type. So Elastic Volumes that support this feature are the current generation volumes. So the GP2s, the io1s, the ST1s, and the SC1s. So you can change the volume type to any of the other 3 volume types. So let's go through some of the combinations. So here we can see that we can change a GP2 volume to an io1 volume. We can also change the GP2 volume to an ST1 volume. We can also see that a GP2 volume can change to an SC1 volume. So again, all the different volumes can change to the other volume types within the current generation volume family. The third capability as a part of Elastic Volumes is the ability to decrease or increase provisioned IOPS for io1 volumes. So you may be asking this question, can I combine different modifications into one? And the answer is absolutely you can. This diagram shows you going from a smaller volume to a larger volume of a different type. And we can quickly walk through some of these combinations. So if we just take a look at the first 2 volumes, you can go from a smaller GP2 volume to a larger io1 volume, or a larger ST1 volume, or a larger SC1 volume. So you can do that with all 4 different volume types. A couple of things to keep in mind though. The volume modification you are requesting must be valid for the target volume type. So, if you can create a new volume with the volume characteristics you're planning on using when issuing the volume modification command, really how you want your target to look like at the end, then it's going to work. So let's go through a couple of examples. So say we have a 400 gigabyte GP2 volume, which we want to modify so it becomes a 400 gigabyte ST1 volume. Can we do this? If you're in the chat window, you can say yes or no. You can respond back. Are we able to change a 400 gigabyte GP2 volume to a 400 gigabyte ST1 volume? Well, if we know the different volume characteristics of the ST1 volume, we know that the minimum size of that volume type is 500 gigabytes. So no, that change would not be allowed because the modifications we're requesting are not valid for the target volume type. We could then go to a 500 gigabyte volume for this example though. So again, if you can create a new volume with the volume characteristics you're planning on using as an end result of the modified volume process, basically how you want your target to look like at the end, then it will work. If you create a new volume and the volume characteristics you're planning on using when you're issuing the modify command, then of course it's going to work. This is really a common, this example here is a common modification because we have a lot of customers with big data or analytics workloads that were running on GP2, but they wanted to take advantage of some of the sequential throughput characteristics of the ST1 volumes, but they couldn't take downtime in order to make this volume change. Now they're able to do this. Let's look at one more example. Say we want to increase the PIOPS of an iowan volume. In this example, we want to go from a 100 gigabyte iowan volume with 1,000 IOPS to a 100 gigabyte, 10,000 IOP iowan volume. So if we know the characteristics of the iowan volume, we know that the maximum ratio of IOPS to size is 50 to 1. So in order to get the 10,000 IOPS that we want, we would have to increase the size of the volume. So we would have to go to a 200 gigabyte volume. Then we could make this modification. So it's good to know the different volume type characteristics. So when you're going to make a volume modification, there aren't any surprises. So knowing the minimum size of each volume is good. For instance, for a GP2 volume, the minimum size is 1 gigabyte. For a iowan volume, the minimum size is 4 gigabytes. And the minimum size of the ST1 and SC1 volumes are 500 gigabytes. It's also good to know the maximum size of the current generation volume. So they can all go up to 16 terabytes. So you can't create a 17, 18, or a 20 terabyte volume. It's not going to work. It's also good to know the minimum maximum throughput or IOPS for each of the volume types. And it's also good to know that maximum ratio that I referenced earlier of IOPS to size for the iowan volume, which is 50 to 1. So, some of you may be asking yourselves, well, where can I use elastic volumes today? Well, what number is going to pop up? 3. That's right. So I had to make this is sort of a stretch using 3, but I made it work. So it's available in all public AWS regions today. Current generation volumes, as well as current generation instances that can take advantage of live volume modification. So if you're running in any of our public AWS regions, you can take advantage of these elastic volume capabilities today. If you're using current generation EBS volumes, the ones we've already discussed, the GP2, iowan, ST1, or SC1 volume types, you can take advantage of these capabilities today. Our previous generation volumes, also referred to as magnetic volumes, do not support elastic volumes. Our current generation instances also support elastic volumes. Some of the previous generation instances do not support live volume modifications. There's a couple of caveats that I want to dive a little deeper in as well. So, all M3 mediums support live volume modifications. So if you sort of keep that in mind, if you have M3 mediums, you're good to go. You're able to take advantage of live volume modifications. M3 instances other than mediums do not support live volume modifications After each volume modification, you must do a stop-start of the instance or a detach or an attach of the volume. So these are some of the other M3 instances out there other than medium. Do not support live volume modifications unless you go through these steps. Now, for all other instances out there, in order for you that have EBS volumes that were attached before November the 1st, 2016, they do support live volume modifications only after a one-time instance stop-start or if you detach and attach a volume. If you have EBS volumes attached after November the 1st of 2016, you're good to go. You can take advantage of live volume modifications today. So, how many tools do you think we can use to modify volumes? You guessed it, 3. So we could take advantage and use the AWS Management Console. We can use the CLI, and we can use the SDKs. So the Management Console, very easy. Go into the EC2 Management Console, select volume, select the volume you want to modify. Actions, modify volume, put in the characteristics of that volume, click Modify, confirm, and then you're good to go. With the CLI, it's even easier. We give you a new CLI command, so if you need to update to the latest CLI. We give you a new modify volume command. And as I mentioned earlier, you can also leverage any of our SDKs to make this volume modification as well. So, what can I expect when doing a volume modification? Well, you guessed it. There's 3 expectations that you will have. No performance impact. So there are some challenges with changing volume types using snapshots or over provisioning volumes because you just couldn't tolerate downtime. So, or even to provision larger, faster volumes. So there's no downtime associated with this and no over provisioning. A great example of this is really with one of our customers, Atlassian, HipChat. They over provisioned some of their iowan volumes for their Elasticsearch cluster. And they were looking at ways to scale down their provisioned IOPS from 6,000 to 3,000 per volume. So with this elastic volumes feature, they were able to save 4 to 6 weeks of engineering efforts and reduce cost, and it had no impact on the customers. So when I say no performance impact, what does that mean? So that means that the volume performance, there will be no performance impact as a result of this process. The volume performance that you see is going to be in between the original volume performance and the target volume performance. So let's go into that a little deeper, okay? So it looks like this. Your volume performance will be between the original volume performance characteristics and the target volume performance characteristics. So in this example, we have a 1 terabyte volume. It's a GP2 volume, and we want to modify it to a 1 terabyte iowan volume. The GP2 volume has 3,000 IOPS, and we want to modify it so the 1 terabyte iowan volume has 20,000 IOPS. The performance is going to be in between 3,000 IOPS of the original volume and 20,000 IOPS of the target volume during the modification process. And a little later we'll go into the specifics of what do I mean by the modification process. Let's do one more example. So say we have a 10 terabyte iowan volume. We want to modify to a 10 terabyte ST1 volume. In this example, we'll be going from 20,000 IOPS to only 400 IOPS. But if we understand the characteristics of the iowan volumes and the ST1 volumes, we'll know that we're going from basically a block size of 16 terabytes, or a size of 16 kilobytes, to a 1 megabyte. So really the throughput is going to be changed from 320 megabytes to an increase of 400 megabytes with the ST1 volume. Because in this example, the application is really designed for larger I/O, they're able to take advantage of the increased throughput while decreasing the cost. So you could see, if you have an example like this and a workload like this, you could see up to maybe 80% cost savings of a 10 terabyte iowan volume running at 20,000 IOPS, which gets around 320 megabytes per second, to a 10 terabyte ST1 volume, which only runs at 400 IOPS, but because of the I/O size, you're able to get 400 megabytes per second. But you can get this at a substantial cost savings. So, how do I modify the EBS volume today? Well, of course, there's going to be 3 steps. First step is modify. The second step, we want to monitor the progress of the modification. And the third step is optional depending on if you're increasing the size. So if you're increasing the size of your volume, you will need to extend the file system. So let's go a little deeper. So in this example, in the EC2 console, we select the volume, actions, we select the volume type, we select the new volume type that we want to change to. So the target volume, we would change the size of the volume, we would change the IOPS if we wanted to, if it's an iowan volume. We would select modify, and then we would confirm that modification. So very easy doing it through the EC2 management console. From a CLI, you will need to use the EC2 modify volume command. So let's go through a quick example of this. Say we have a volume ID. It's a 1 terabyte GP2 volume with 3,000 IOPS. We want to modify it so it becomes a 5 terabyte, 20,000 IOPS iowan volume. The modify volume command would look something like this. You would pass in the volume ID of the original volume. You would pass in the target volume size, in this case 5 terabytes. You would pass in the volume type, the target type, which is iowan. And because iowans, we need to also specify the IOPS. We would specify the target volume IOPS, which is 20,000. So with this understanding, we will know that the performance of our volume during the modification process is going to be in between the 3,000 IOPS of our original volume and 20,000 IOPS of our target volume. So we can also monitor this progress through the management console. So if you just refresh, after making a change, refresh the volume, you'll see the state change from modifying to optimizing just within a few seconds. You can also take a look at the target and original volume characteristics so that you know what you're going from and to. And this you can monitor just through the AWS console. You can also monitor it through the CLI. We give you a new command, the describe volumes modifications command. So let's go back to our example and see what this would look like. So we would pass in the original volume ID of our volume in the describe volumes modifications command. And the results would look something like this. We would see the original volume characteristics, that it was a GP2 with 3,000 IOPS and the original size. We would see the start time when the modification started. We would also see the target volume characteristics. So the target volume size, the target volume type, as well as the target volume IOPS. And again, the performance is going to be in between the 3,000 IOPS and the 20,000 IOPS, in this example, during the modification process. So you can also monitor the progress of your modification using CloudWatch events. With event-based monitoring, you can actually fire off a Lambda function to take some type of action, or you can send a notification to someone notifying them to take an action. To help you out, we have a couple of examples out there in our AWS Labs repository. So in this example, we actually give you a Lambda function that will help you modify resize the volume that is managed as a part of the system's management service. So when you're modifying the volume modification really goes through a number of different states. So I'm sure you can guess how many states it actually goes through. Right, it goes through 3 different states. So let's go through each of these states in a little more depth. So the modifying state. This is a very short, usually takes just a few seconds. And that's really to notify you that yes, we received your modification request and we're working on it. As I said, this is only a few seconds. Soon afterwards, you're going to go, the modification will go into an optimizing state. And this could take anywhere from minutes to hours depending on the type of modification you're doing, as well as the workload that is going on your original volume. So with volume type modifications, let's go into a little more details. As I mentioned, your volume performance is going to be between your original volume target and your performance target during this optimizing state. So again, it's going to be in between the original and target performance characteristics during this state. If you're increasing or decreasing provision IOPS, in the optimizing state, again, you're going to have performance in between the original volume and the target volume. And this is only during this optimizing state of the modification. Now, if you're increasing the volume size, as soon as you enter that optimizing state, the volume is the target size. So now you're able to take advantage of that. So then you would go to the next step and really extend the file system of the OS so that your file system can now gain access to that additional storage that you added as a part of the extending your volume. Then finally, the last state is basically letting you know that it's done. The modification is complete. You now have a new volume type with the new characteristics that you identified during the modification process. So, as I mentioned earlier, if you're doing a size increase, you will need to extend or resize your file system. So the first thing you want to do, you want to make sure that you understand what file system you're running for that volume. So you can issue a command like this to identify the different file systems for the different volumes. After that, you can actually sort of compare what the block size is showing you compared to the file size of the disk that is associated with that volume. And if you extended the volume, you're going to see that there's going to be a difference of size. Your block size is going to be larger. Depending on the file system that you're using, you will have to run one of these two resize file system commands. So for ext2, 3, or 4, you'll need to use the resize2fs command. If you're using xfs, you'll need to use the xfs growfs command. So for Windows, similarly, you would go into, on the instance, you would go into disk management. You'd right-click the volume and select extend the volume. Then you would just complete the wizard. Put in the amount of megabytes that you want to extend it to and complete it. So, some of you may be asking the question, how often can I modify volumes? So, each volume can be modified once every 6 hours. So you can only issue the command to that specific volume ID once every 6 hours. If you have 2, 10, or 100 different volumes and you want to modify all of them at the same time and run these modify volume commands in parallel, you can do that. You just can't issue another modify volume command to that specific volume ID within 6 hours of the previous volume modify command. So another question you may be asked, and if you do that, we will let you know. So if you do that through the EC2 console, we will let you know that you need to wait at least 6 hours, and if you do it through the CLI or the SDKs, we'll also let you know. So once you start a modification, once you execute that modify volume command, are you able to stop it? So the answer is no. You can't stop it, so you need to make sure it's right the first time, because you'll need to wait at least until the modification completes, or 6 hours, whichever is longer, before you can correct it and make the correct modification. So just make sure before you execute that modify volume command that you're making the correct modification. So, can I modify encrypted volumes? So the answer is yes. Yes, you can modify encrypted volumes. You can also modify unencrypted volumes. You cannot change the encryption state though. So it will go from a target volume of encrypted to an original volume of encrypted to a target volume of encrypted. Or vice versa, you can go from an unencrypted original volume to a target volume of unencrypted. You cannot change the encryption state as a part of the modify volume command. So some of you also may be asking, how much does it cost to modify a volume? Well, the modify command is free. There is no cost for issuing a modify command, but you will be charged for the new volume specifications as soon as you issue that modify volume call, as soon as you execute that command. You will then be charged for the specifications of your target volume. It may take minutes or hours for that modification to take effect, but you will start to be charged as soon as we start that process, because we are giving you the ability to have the performance in between the original volume and the target volume. So what about permissions? So there is no performance impact, as I said, as a result of you issuing the modify volume command. But there will be a performance impact, either positive or negative, as a result of you changing the volume type or increasing or decreasing the PIOPS of iowan volumes. For example, if you have a 2 terabyte, 20,000 IOPS iowan volume, and you modify it to a 2 terabyte ST1 volume with 400 IOPS, and your workload can take advantage of the large sequential I/O that ST1 volumes are designed for, then your application could likely be impacted. So what do we recommend? Test your application. Test your application before making those volume modifications, because the end result of the volume modification could be impactful. So what we do recommend is that you lock down the permissions to the modify volume API call, just like you would the delete volume API call, so that only a limited few people are able to execute it, because it can be very impactful to your workload. So let's go ahead and let's walk through a typical modify volume timeline. So in this case, we're going from a GP2 original volume, and we're modifying it so the target volume will be an iowan. First thing we do, we execute the modify volume API call. Takes a second, very, very fast. The modification then goes into the modifying state. And this typically lasts just for a few seconds. When I say few seconds, single-digit seconds. Right after that, it enters the optimizing state. And if you're doing an increase in the size, your target size that you specified will now be available when the optimizing state starts. So you could actually go in and expand your file system to take advantage of the new extended volume. Then at the very end, we go into the completed state, notifying you that the modification has been completed. So let's go into, let's just look at a test modification that I did recently. We have an unmodified volume, or a volume that we're not going to modify. It's a 100 gigabyte GP2 volume. It has an ext4 file system. It is attached to an M4 2 extra large. And we're running FIO, a 50-50 read-write workload, 10 of these against 8 gig files. We're doing this exact same thing on 2 different instances against 2 different volumes. Volumes are identical. On one of these volumes, we're going to modify the volume size from 100 gigabytes to 200 gigabytes. We're not changing the volume type, we're only changing the volume size. So based on that information, can you answer these questions? Which line is the unmodified volume and which is the modified volume? So these lines are IOPS, okay? So because I was doing a 50-50 read-write test, to just clean up the graph, I took off all the writes, so I'm only showing you the read IOPS of the 2 volumes. So one of these volumes, I executed a modified volume command against it, and one of them I didn't. So if we extend the graph a little farther, any other guesses? Is it the orange line or the blue line? And if we go even farther out, do we have any other guesses on which is the unmodified volume and which is the modified volume? This is the modification that we executed. So about half or a few minutes into the test, we issued that modify command, increasing the size of one of the GP2 volumes from 100 gigabytes to 200 gigabytes. So why do we have the change? So to let you know, the volume that we modified was the orange line. And you notice when we executed the modify volume API call, there was no performance impact. But we were actually able to get better performance or longer performance from that volume. And you're probably asking yourself, well, why? Well, that's because when you increase the size of the GP2 volume, when you're under 1,000, remember we have this burst bucket model. We actually put burst credits into your bucket. So now you're getting the burst credits worth of a 200 gigabyte volume. So you could actually burst for longer. After the burst bucket was completely depleted, then the line went down, the performance went down and dropped down to the baseline performance. So you see that the orange line is the modified volume, the 200 gigabyte volume, because it has a higher baseline IOPS, versus the blue line, which was the unmodified volume, and it had just the IOPS of a 100 gigabyte volume. So with that said, let's go ahead and jump over and do a quick demo. So here we have my AWS Management Console. We have a single EC2 instance in the M4 4XL. We see that Attached to it, we have two volumes. We have our root volume, which is 10 gigs, and then we have a 2 terabyte iowan volume set at 500 IOPS. So let's go ahead and log into this instance. And we'll do a little test against it. So let's say yes, we'll go ahead and log into it, and let's go ahead and take a look at this this instance. So if we look at our volumes, we basically we see our 2 terabyte volume out there, and we have this mounted to EV demo. So if we just go over to EV demo, we'll notice that there's nothing in here. It's a blank volume. Nothing is on this volume yet. So let's go ahead and put some load against this volume. So let's jump over here and let's just grab, we're going to do a quick dd command. And we'll take a look at the progress of this. So we see that the dd command is going to start writing data to this volume. We're going to see that it's going to settle down in 100, 120 megabytes a second. So as we sit there and watch this for just a few seconds, we'll notice that it's going to settle down. We've already copied or already generated about 4 gigabytes of data. It's going at a pretty good speed of 138 megabytes a second right now. So if we go ahead and let's go ahead and stop that. Let's run over to our management console. Let's modify that volume. So let's go over to our volumes. Let's select the iowan volume and let's modify it. So let's change it to, say, an ST1 volume, but we need more space. So let's change it to a 3 terabyte volume. We don't have to specify IOPS because that's not applicable to ST1 or SC1 volumes. Go ahead and click on Modify. We'll click on Yes to confirm the modification. Click on Close. Let's go ahead and refresh. And we'll see the state here. The state is modifying. After a few seconds, we'll refresh it again. And we'll notice that the state will go from modifying to optimizing. Now we're in the optimizing state. And we can actually go down here and take a look, and we can look at the target volume characteristics and the original volume characteristics. So we see that we're going from a 2 terabyte 500 IOPS io1 volume to a 3 terabyte ST1 volume. So great. Let's jump back over to our instance. Let's go ahead and rerun that dd command and see if our performance is any better. So we'll see much better performance. The application is really taking advantage of the larger sequential I/O of our ST1 volumes. And by doing this live without doing a reboot or a detach, reattach, the application or the workload now is able to take advantage of, one, the more IOPS or the larger throughput of this volume. And here in a second, we'll take advantage of the larger size as well. So let's go ahead and exit out of that. And we're going to go ahead and resize that. So let's look at the block size. We see that it is 3 terabytes. We'll see, though, that our file system is only 2 terabytes. So we need to go ahead and execute that resize to fs command. So by executing this command and resizing the file system, now we're able to take advantage of that additional space. And now we see that our file system is 3 terabytes.